Okay, let's start now. Okay. Good morning, guys. Welcome to NEET World Institute and NEET World YouTube channel. Yes. So this series is about EAPCET program for both engineering and medical stream students who are going to appear for 2026 examinations, right? Yes. So we were discussing about a topic laws of motion, right? And where we left, from that we will continue from today's class. So before that, we'll wait for 1 or 2 minutes. The people are joining over here. Okay. Yes. Yes. Can we start now? Okay, fine. Let's start now. So we were discussing about a topic spring force, right, in last class. So spring force, so which is denoted by the letter F and S, right, Fs. Now two things we were discussed. One is what is the spring force formula. The second one is whether it will be acted in series condition or the parallel condition, right. So spring force is directly proportional to the expansion or compression, right? No, so X is nothing but the expansion or compression, we will say. So which is spring force is will be equals to Kx, where K is called as spring constant. Spring constant. Second one, what we have discussed here, if it is in series and parallel condition, series and parallel condition. So for series condition, the formula will be 1 by Ks will be equals to 1 by K1 plus 1 by K2, right? No, 1 by K1 plus 1 by K2. So for parallel, it is K parallel will be equals to K1 plus K2, right? This is the formula. Right? Yeah. Sorry for the interruptions. Okay. Now, yesterday we have discussed about a question which was a combination of a rope and a spring, Now we will discuss a question when they will ask in a spring, like a two combined spring, either in a series condition or a parallel condition, and what will be the expansion or extension of the spring or compression of the spring, whatever we will discuss now, right. So now the question is there is a there is a spring. First it has been connected by a block A and another spring is connected by a block B, or let me take, okay, so first spring K1 and again one more spring K2 connected by block A or mass M, this is K2. So what will be the extension of the spring? Can you find what is the extension, that is x value of the spring, right? So this is the question, this is the mass M, okay, this is the question. So how to find is, I need to know whether the spring are in the series or parallel. So if I see these two things, no, it is in series condition. So series condition in the sense when they are connected one by one. So this is K1 and this is K2. When they are connected like this, this is my parallel K1 and this is K2, right. Now if I talk about this two springs, I need to know about the effective value, K effective I need to know. So to know the K effective, I have found that it is in series condition. So series condition formula is 1 by K effective, let me write here only, 1 by K effective will be equals to 1 by K1 plus 1 by K2, 1 by K1 plus 1 by K2. So 1 by K effective will be equals to K2 plus K1 by K1 K2. So if I reverse this, I will get the K effective value. K effective will be equals to K1 K2 by K1 plus K2. So this is my K effective value. I need to use the value of K, this only, okay, in place of this K value, okay, K effective I need to use. Now the formula is, since if I talk about the free body diagram of this condition, no, so yeah, now if I talk about the free body diagram, no, this is my K effective now, K effective, and this is my, this is F, the spring force, and this is my weight W. So both are in the opposite direction, right? Yes. Now the free body diagram I have written, now I can write the equation, I guess, right? So Fs will be equals to W, right? Fs will be equals to W. So what is W? That is mg, which is nothing but mg. So this is K effective into x will be equals to mg. So x will be equals to mg divided by K effective, which is nothing but 1 by K effective, no? I can write this as mg into K1 plus K2 by K1 K2. This is my extension of the spring. So answer is x is equals to mg into K1 plus K2 by K1 K2. So when they are in the series condition, okay, if they have given 3 springs or 4 springs or n number of springs, I can use like this. Suppose if they have given in this condition, no, like this is my spring, they have attached here. So now what I should do? I need to calculate in terms of parallel condition, K1 plus K2 plus K3 up to Kn. How many springs are there? That many springs I need, spring constant I need to add it. Then I need to substitute the same values here. K effective, x will be equals to mg. So K effective will be taken in other side, so will be mg by K effective, right? So for the parallel condition, if 2 springs are in parallel, what should I do? X will be equals to mg by K effective, nothing but mg by K1 plus K2, that's it, this is my answer. Yeah, the question is like, yes, the thing you need to understand is, if they have given in equilibrium condition, if they say that this is in equilibrium condition, then only I can mention that spring force will be equals to W. Okay. If they are moving now, like I can use the condition Fs minus W or W minus Fs will be equals to mass into acceleration, right. So, the thing, if they mention the condition is in equilibrium, I can use the equation spring force equals to the weight. Okay, done. So, can we go for the next topic now? Okay, done. So, next one is friction. So, friction. Okay. So, what is the meaning of friction and which side the friction will act? This thing we have discussed in the first class, right. So, friction is nothing but the opposing force will be acting in the opposite direction, right. It is an opposing force, it is an opposing force and will act in opposite direction. Now, suppose if a body is moving, in right direction, okay, some F has been applied, external force has been applied on the object, right. So, it is going in the right direction, like this is the acceleration direction, okay. So, think that it is a rough surface. So, what happens if the rough surface is there, like some uneven will be there, after I am applying some force on an object, it will go to the certain distance, again it will get stopped. So, it depends upon the how much the surface is the rough, right. So, opposite side the friction will act. So, opposite side the friction will act. So, which is denoted by the letter small f. Okay, we are going to use friction in terms of small f. Okay. Now, we will study about the two important types of friction. I mean, totally three will be there. Okay, one is static, second one is kinetic, and third one is rolling friction. So, two things we are going to involve in this lesson. Okay. So, rolling when it comes to in this rolling will be coming in circular motion, that one we will study separately. Okay. So, the first one is a static friction. Okay, let me explain static and kinetic, both I will say. When the object and the surface are relatively at rest, is called as static friction. When object and surface are relatively in motion, is called as kinetic friction. Static in the sense it is a rest, kinetic in the sense it is in motion. So, I can say that when the object and the surface relatively at rest, it is a static. Object and surface relatively in motion, it is kinetic. Okay. So, this friction is directly proportional to the normal force, right. So, to remove the proportionality, we are adding a constant called mu. So, F is equals to mu n is the formula for the friction, where mu is the coefficient of the friction, So, this mu it depends upon the surface, okay, it depends upon the surface, and they will mention the value if a problem is given, or else we need to find what is the value of mu. This will be the kind of question they will ask in the examination, right. and this static friction is denoted by F is equals to mu s n, where mu s is the coefficient of static friction and F is equals to mu k n, where mu k is the coefficient of kinetic friction, right. So, this is about a glance of a friction. So, its opposing force will act in the opposite direction, and two types of friction we are going to see, one is a static and second one is a kinetic. So, the static friction formula is F is equals to mu s n, and kinetic friction F is equals to mu k n, okay. And we know that a friction is nothing but F is directly proportional to the normal force, this is normal force, okay. So, to remove the proportionality we have added a constant called mu, from this formula only we have got this formulas, okay. So, mu is nothing but coefficient of friction, right. Yeah, you can take a note of this, we will go and see some problem related to these topics. Okay. So, the next one what we are going to see is, suppose object is there, right, an object is there, and here a force has been applied F y in y direction, like its y axis, here another force has been applied, this is F x. Now, the thing is, a friction will be there, like a static friction or kinetic friction, whatever it is. So, will be acting in this direction, right. Now, this is F s. So, what is F s? How to find that F s? So, to find that F s, the formula is F s will be equals to root over F x square plus F y square, right. This is the formula. Done? Okay. The next one is important thing, they might ask question based on this. Okay. So, what is the note point? What is the relation between static, kinetic and rolling friction? So, they can ask question based on this three relation. Yes, rolling friction we will study in the circular motion. Before that, we will know what will be the relation for these three things. Okay. So, similarly, when I talk about static and kinetic, rolling friction also like denoted by mu r. So, mu s is static, mu k is kinetic, mu r is rolling. So, the relation is mu s greater than mu k greater than mu r. So, this is my relation for static, kinetic and rolling frictions. Okay. Yes, completed. Can we see questions now? Okay. So now we will see the questions. So let me read out the question. Okay, 20 kg block initially at rest, a 75 Newton force is required to set a block in motion. After the motion, a force of 60 Newton is applied to keep the block moving with constant speed. The coefficient of static friction is. So what is the coefficient of static friction they are asking? This is the question. Wait a minute, let me arrange the camera. It's getting blurred, right? I guess it's clear now. Yeah, guys. Done. Yeah. So let me read out the question once again. Okay, 20 kg block initially at rest. Okay, there is a 20 kg block initially at rest. Then what happens? A 75 Newton force is required to set the block in motion. Okay, fine. After the motion, a force of 60 Newton is applied to keep the block moving with constant speed. Constant speed they are saying. Okay, so constant speed in the sense acceleration will be 0, right? Fine, done. Then coefficient of static friction they are asking. What will be the coefficient of static friction? So can you give an answer for this question? Okay, whoever watching in online, no, they also can give answer in the comment boxes. 60 Newton, like 75 Newton initially, it is going with some it's going with some velocity, but after that it has been a constant velocity, right? 60 Newton. So can I say 60 Newton force has been applied and opposing force is F. So F is equals to F, yes, no? Why F is equals to F I am taking? Because the thing I have applied, okay, it's going with the constant speed, they have told, fine. Acceleration, like constant velocity means acceleration will be 0, right? So acceleration 0 in the sense I have taken F is equals to F. So F is 60, I will keep as it is. What about small f? It is mu S into N. What is N, guys, now? N is nothing but, let me draw the free body diagram for this case. So free body diagram will be looking like this. This is normal force and this is weight. So normal force will be equals to mg, where m is nothing but 20 and g is nothing but 10. So it is 200. So 60 by 200 will be equals to mu s. This is my coefficient of static friction, right? So this is how we will proceed with. Yes, Gautam. Yeah, approximately we will get to 0.3. Done. So can we go for the next question? Okay. So the next question is, okay, a block of mass 10 kg, moving with acceleration 2 meter per second on an horizontal surface, So block of mass 10 kg is going with 2 meter per second square on horizontal surface. This is a rough surface. rough surface. Okay. Now a force has been applied here is 40 Newton. Because of that force, it is going with 2 meter per second. So what is the coefficient of friction? Coefficient of kinetic friction. Here again it got blurred. Yeah, now it's clear, I guess. The blur is not there, no? Okay, fine. Okay. So since object is going with some acceleration, I can say object is in motion, and I can say that it's a coefficient of kinetic friction, right? So find coefficient of kinetic friction for this question. So who is going to give answer for this question? Guys, whoever watching in online, you can give answers in the comment boxes. Let's check. Okay, can we solve the question now? Um, 0.2. Okay, it's correct. 0.2 is the correct answer. Gautamish Vilasya, it's correct. Yeah, let's find now. Okay, so free body diagram will be looking like this, no? This is my force and this is my friction F, and the acceleration is in this direction A. So how can I write the equation? So F minus small f will be equals to mass into acceleration. F is 40 Newton and minus it is mu into n will be equals to mass is 10 kg and acceleration is 2, right? So 40 minus 20 will be equals to mu into n. So 20 divided by how much it is, mg, right? M into g will be equals to mu, that is mu k, right? It's a kinetic friction, no? Okay. So what is mass? 10 kg. Gravity we will take as 10 approximately. So 20 by 10 into 10 will be equals to mu k, where it is 0 will get cancelled off. 2 by 10 will be equals to mu k, where mu k will be 0.2. And guys, is there any unit for this coefficient of friction? Coefficient of friction, is there any unit? No. So there is no unit for coefficient of friction because F is directly proportional to n, where F is also force, n is also force. So F is equals to mu n, where this is a Newton and divide by a Newton will be equals to mu. So Newton and Newton will get cancelled off. So there will be no unit for mu, right? So the answer is 0.2. Can we go for the next question now? Okay, so the now question is given like this. I will read out the question. A block of mass m, lying on a rough surface, like rough horizontal plane, okay, is acted upon by a horizontal force P and another force Q which is inclined at an angle theta with respect to vertical. The block will remain equilibrium condition. Okay, so the coefficient of friction between the blocks. Let me draw the diagram for this question and can you give answer for the question? Okay, so the question is given like this. So, there is a block of mass m which is lying on the rough surface. This is rough surface. One force acting in this direction, like horizontal direction, that is P, and another force acting at an angle theta with respect to vertical, that is Q. So, can you find what is mu here? System is in equilibrium condition. System is in equilibrium condition. Okay, this is the thing they have given in the equation. So, what will be the mu value? What is the value of mu? So, who is going to give answer for this question? Done? Guys, you can give answer in the comment boxes who are watching here. We'll check the answers now. Yeah, I'll give another 30 seconds time. You can fast. You didn't get the answer. Why? From where did you make the mistake? Okay, we'll check the answers. Okay, I'll do the thing so that if you are not getting, tell to stop. I'll explain once again. Okay, right, fine. Now what I can do is here, system is in equilibrium condition. No, it is in equilibrium condition, so there won't be any acceleration. So acceleration will not be there. So I can say that F is equals to the whatever the forces are acting will be equals to the kind like frictional force. So whatever the forces are acting, here P is acting, Q is acting. So the sum of force will be equals to the frictional force, right? So the free body diagram for the mass m, this is my P and this is my Q, right, will be acting with respect to, wait a minute, yes, with respect to vertical, this is Q, this is P, and the frictional force will be in this direction, that is F, right. So I need to resolve this first. The angle which is close to the axis is nothing but cos theta, away from the axis is sin theta. So in this direction P is acting, again in this direction Q sin theta is acting, right, and in this direction the frictional force is acting. Now whatever remaining things down, it is weight, and again a normal force is there, this is my normal force and this is my Q, how much, cos theta, right, Q cos theta, that's it. Is there any doubt now? Normal force we got, weight also we got, we have resolved the value of Q also. Now I can write the equation. So P plus Q sin theta will be equals to F, where F is equals to mu into N, right now. So P plus Q sin theta will be equals to mu n. Now what is n here? N is acting above and two normal force, the weight and Q cos theta acting downwards. So n will be equals to W plus Q cos theta, where W is mg plus Q cos theta is nothing but normal. So P plus Q sin theta will be equals to mu into mg plus Q cos theta, where mu will be equals to P plus Q sin theta by mg plus Q cos theta. This is the answer. Got it? That's the answer for the mu. Is anyone having any doubt in this question now? And whoever watching in online now, is anyone having any doubt in this question how to solve now? And Gautamish, Vilasya, yes, you got the answer? Understood? If you have understood, please give a comment like yes. No sir. Okay, let me explain once again. Wait. Okay. So this is the question, right? Like P is one force and Q is one force. P is acting horizontal direction and Q is acting with some angle with respect to vertical. So I need to resolve this Q in y direction and x direction. So for resolving, this is the free body diagram. Okay. So resolving, no. So normal force will be upward and weight will be downward. So if you resolve this Q, no, this one will be downward, will be cos theta, and in horizontal direction it will be sin theta. Why cos theta? Means theta is close to the axis, vertical axis. So it is cos theta. Away from the horizontal axis is sin theta. So P plus Q sin theta, like this arrow marks are there, no, like this arrow marks should equate it. P plus Q sin theta, P plus Q sin theta should be equals to F, and P plus will be equals to mu n. F is nothing but mu into n, no. So now the normal force, if I talk about, normal will be acting upward direction and weight and Q cos theta will be acting downward direction. So I can substitute the values here. So from this equation I need to get the value of mu. So mu will be P plus Q sin theta by mg plus Q cos theta. So this is the answer. So now you got it? So anyone having any doubts in this question now? Fine. We'll go for the next question. Okay. So the next question is, the coefficient of friction mu, the coefficient of friction is mu and the angle of friction is lambda, angle of friction is lambda, okay, are related as, I guess the camera is clear right now, it's getting blur, okay. So the coefficient of friction is mu and angle is lambda. So what will be the relation they are asking? What will be the relation? Like the force is acting with respect to lambda now, okay, with respect to lambda. So what is the relation they are asking? Yes, so easy, no, like I can say directly it is mg sin lambda and mg cos lambda it will come, or m sin lambda cos lambda. Two things I need to take, right? No. So what will be the relation now? Can you say now? Okay, the answer will be fine, that's correct. Mu will be equals to tan lambda, that's it. How? Yes, it is mg sin lambda will be equals to mu into mg cos lambda, right? No. Yes. So the force is acting by mg sin lambda in horizontal direction and mg cos lambda in vertical direction, right? Yes, no? Now this mg and mg will get cancelled off. Sin lambda by cos lambda will be nothing but mu, it is tan lambda. Okay. Next question. A force of 98 Newton is required to just start moving a body of mass 100 kg, over a ice. Okay, ice is there. Okay, so there is a mass of 100 kg is there and force of 98 Newton is required to just kickstart. Okay, so what is the coefficient of friction now? What is the coefficient of friction? That is static friction. Yeah, you can use here GS 9.8. Okay, GS 9.8. So let me draw the diagram here. So the diagram will be, there is a block of mass 100 kg and the force has been applied, that is 98 Newton, and it's a ice. Okay, it's a rough surface only. Now what is the thing they are saying is, I need to find the value of mu. This is the equation. So F is directly proportional to F. I mean F is equals to F. To just kickstart, no, to just kickstart. So F is equals to F. So F is 98 will be equals to mu s into n. So 98 will be equals to mu s. What is n? Sir, n it is nothing but 100 into 9.8. That's it. 100 into 9.8. So mu s will be equals to 98 divided by 100 into 9.8 will be nothing but, this is 1 times and this 1 times will get cancelled off. I will cancel 1 0. So 1 by 10 will be nothing but 0.1. So 0.1 is the static friction. 0.1 is the static friction. Yes, 0.1. That's correct answer. Done. So can we go for the next question? Okay. So the now question is, yes, I am going to involve the tension and the weight, then frictional force, normal force, everything in this problem. Okay. The question I am going to read out now. Before that I will draw the diagram here. So there is a surface, and a block A has been kept here, block A, right, and here they have connected a pulley. So this is my pulley and they have connected another block here, that is B, another block B. Okay. So this is the case. Now I will read out the question. The block A and B are arranged as shown in the given figure. A pulley is frictionless. See, pulley is frictionless. Okay. The mass A is 10 kg. The coefficient of friction of A is, this is 10 kg, A is equals to 10 kg, and here the coefficient of friction is equals to, it is 0.20, okay. The minimum mass of B to start motion will be, I need to find what is the mass of B, this is the question, the minimum mass of the B. So can I give answer for this question now? Yeah. So what is the answer? Yes, first need to draw the free body diagrams, right. So what will be the free body diagram? So first one, A is there. If I talk about A, the free body diagrams will be, this is my tension T and the frictional force will be acting in opposite direction. This is my normal N and the weight will be acting towards down MAG. So these are the free body diagrams of A. This is the free body diagram of A. Then B, the B will be having tension T and it is MBG. So that's it. Is there any other thing left out in this? That's it, no? Yes, fine. Now let me write the question. So to just kickstart, they are saying, no, to just kickstart in the sense like I can equate the things. So from this I can say that T will be equals to F and T will be equals to MBG. Mass of B and G. So if I find what is T, I can substitute the value of T here and I can find the value of mass B. Just do this. T will be equals to, F is nothing but mu into N, where N is nothing but, N is nothing but M A into G. So will be equals to mu into M A into G will be tension. So what is mu? How much they have given mu? 0.02. So 0.02 and mass of A is 10 kg. 0.02, no, 0.02, right? Sorry, 20, sorry, it is 20. Yes, 20 into 10 into 10, that's it. You will get the value of T. Fine. Next, take that value and substitute in the second equation. So how much it is? 2 zeros and this 2 zeros, 2. So tension will be 2. So T will be equals to MBG, like mass of B and G. So 2 will be equals to mass of B and the gravity G is 10. So mass will be 0.2 kg. So everyone got the answer for this question? 0.2. Right? Okay. So with this I will stop today's session and we'll see some more questions and the next topic we will start in the next upcoming classes. Okay. So until then we'll meet in the next class, guys. Bye bye. Bye guys.